Now, let us discuss the next topic in motion in a plane, that is horizontal projectile. Horizontal projectile. Horizontal projectile. See, horizontal projectile means you are projecting this body horizontally from certain height. Let us consider you are at a top of a tower of height h. You are projecting the body horizontally with velocity u from top of a tower. Now, this body will travel like this and it will fall to the ground like this. Okay. Now, in this case the same thing, you have to find at what distance it will fall from the foot of the tower and how much time it will take. This is also two dimensional motion. So, here we can take the reference point from top of the tower or from the bottom of the tower, that is your wish. Wherever you are taking, physics will be same. So, concept always remains same, methods may be different to solve problem, but answer should be same only. So, you can take your reference point from 0, 0 from top of the tower or from here, but I will take this as the reference point. See how I am going to fix the coordinate axis. This is the reference point 0, 0, this is height of the tower and motion is present only in 1, 2, 3, 4th quadrant. So, it is fixed in 4th quadrant. Now, based on that I will write initial velocities. So, initial velocity u bar, I given u I cap, but no velocity is given along y axis. Here no velocity is given, just I given along x axis, body is falling like this. So, 0 j cap. Similarly, acceleration you already know, earth always attracts towards the center of the, towards its center. So, acceleration, there is no acceleration along x axis, 0 I plus minus, because it is acting down, minus g j cap. Next you can find at each and every point at time t is equal to 0, particle is here. After some time particle will have both Vx and Vy, and particle will cover both x and y. It will cover distance in horizontal direction and vertical direction. Vertical direction it is decreasing, horizontal direction it is moving forward. So, all these things you have to find. So, similarly like yesterday's class or like previous video which we discussed about oblique projectile, same method will follow. We will apply equations of motion both in x axis as well as y axis. Then our intention is to find at what distance, at what time the particle is present at what coordinate axis, at where it is present. So, what is its velocity after some time, what is its displacement after some time, and after completing its journey where it falls, that is the question. So, here first you take Vx is equal to Ux plus Axt. So, Vx is equal to, you will get u only because acceleration along x axis 0. Now, write Vy minus Vy is equal to Uy plus Ayt. This is minus Vy is equal to, minus Vy is equal to, you will get minus Gt. So, Vy is equal to Gt you can write, but according to our coordinate axis V bar is equal to what you will get, V bar is equal to, this is u I cap minus Gt j cap. That means I took the reference point from there. But velocity increases, but increases in opposite direction, increases downwards. That is the reason. That is the, if you take magnitude, it is nothing but Vy is equal to Gt. Okay, Vy is equal to Gt. This is the condition of magnitude. Next, x is equal to distance travelled uxt plus half axt square. Similarly, y is equal to uyt plus half ayt square. Now here what you will get, x is equal to u into t, because ax is 0. Similarly, y is equal to what you will get, y is equal to, what is acceleration, what is velocity, initial velocity along y direction. There is no initial velocity along y direction. When I project horizontally, I can't say that I have given some velocity in y direction, I have given only in x direction. So uyt will be 0, then y is equal to minus half gt square, and this if you take it as, if you take magnitude, you will get half gt square, and y value is decreasing with time according to my reference point. Now similarly, v square minus u square you can apply, we can't apply v square minus u square here because it is already 0. Next, if total height it is travelling, here I can write h is equal to half gt square, it reaches the bottom, time taken to reach ground is under root of 2h by g. Now range is equal to u into total time, that is u into under root of 2h by g is the formula of range. U into under root of 2h by g is the formula of range. R is equal to u into under root of 2h by g is the formula of range. Next, similarly, v square minus u square you can apply here, vy square minus uy square is equal to under root of is equal to 2gy, uy 0, then v uy is equal to, you will get it as root of 2g h upon reaching the ground. Now you can observe these two formulas carefully. From your motion in a straight line, you will get one conclusion here. This motion I can define in x axis and y axis very easily. If you observe this, it is a body travelling with uniform velocity with velocity u. See here, it is travelling with velocity u, there is no change in the velocity, uniform distance it is covering. But if you observe these formulas, v is equal to gt you got in freely falling body. So freely falling body also has same formula, h is equal to half gt square you got in freely falling body. Time of descent of freely falling body you got under root of 2h by g, and velocity on reaching ground is under root of 2gh. These are all the formulas of freely falling body. Therefore, I can define this horizontal projectile motion as a body travelling with a velocity u along x axis, with a uniform velocity u along x axis, and a freely falling body along y axis, and a freely falling body. For oblique projectile, how you define? It is a body travelling with a uniform velocity of u cos theta along x axis, and a vertically projected body with a velocity of u sin theta in y axis. So this also can be explained as it is a body travelling with a uniform velocity along x, and it is nothing but a freely falling body along y. It acts like a freely falling body. Suppose here I am projecting with velocity u, at the same time if I drop one body from the same height, or otherwise I am dropping from here, let us assume I am dropping from same height, both are given simultaneously, both are released simultaneously, then they will reach time at the same, they are going to reach the time, they are going to reach the ground at the same time, during same time interval they will reach. So this is what is called horizontal projectile motion. And here you can find theta also. So this is the direction of velocity. You can find angle made with x axis. Tan alpha is equal to Vy by Vx. And at what distance it is falling from the tower is nothing but range r is equal to u into under root of 2h by g. So with this we finish horizontal motion formulas. Just you can go through this and you can start solving the problems on horizontal motion. In the next video we will discuss some cases and problems based on horizontal motion. Thank you for joining me. If you have any doubts, you can leave in the WhatsApp group, and if you have any comments, you can comment in the comment section, and please subscribe my channel and share the videos. Thank you.